Hey folks, Tim Berglund here. We're taking a little break over the holidays, and so for the next few weeks, we're going to be re-releasing some of our most popular episodes to date. Before we do that, I want to say thank you to a few people. I want to say thank you to our designer who helps our thumbnails look great and does other branding work for the podcast. Of course, our editors who actually produce this stuff and make the sound and the video look wonderful. Such a big thank you to them. To all my guests who have been on the show. Some of you have been on the show more than once, which, that's really the true test there, and I appreciate it so much. And of course, to every single listener. If you're listening to my voice right now, thank you for subscribing, for listening, for sharing, for writing reviews, all those things you do. And, I want to ask you, keep that up. Keep spreading the word about this podcast. We are continuing this work next year. And in fact, adding a little something. If you missed the episode last week, you should go back and listen to that. It's a sneak preview of a series we're adding next year, in addition to our regular weekly episodes, called Keyboard and Quill, which is going to be a deeper dive into the trends and history and ideas behind the work that we do here. Kind of like Radiolab meets the History Channel. So I'm excited about that. So on to this episode. This is number 14 from this year, my interview with Robert Metzger. It was part 1 of 2 on Apache Flink. Go ahead and listen in. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, coming to you from the StarTree studios today, hence this black background. And I'm excited to welcome my guest today, Robert Metzger. Robert is the PMC chair of Apache Flink and a staff software engineer at Decodable. Robert, welcome to the show.
Thank you. I'm really excited to be here and talk about Flink today.
Nice. And that is exactly what we're going to talk about. In fact, dear listener, this is going to be a 2-part episode, so there's a lot to cover. This really is an introduction to Flink, and today in this episode, we want to talk about architecture and operations and kind of theory and approach to things. And in the next episode, we'll talk about APIs and especially Flink SQL. So that's kind of what we want to do. And Robert, so to the uninitiated, what is Flink?
Yeah, that's a good question. So I think Flink is a framework for building real-time or stream processing applications. The Flink website says stateful computations over data streams. So I think that's quite abstract and theoretical.
Right.
But so at the end of the
you still don't with that, right?
But at the end of the day, the most common way people use Flink is a Java API. So you define a number of sources, like a Kafka source, a Kinesis source, or a CDC source. Then you're applying a bunch of transformations, like filtering data, mapping data, like transforming data. And then you can also do more complicated operations like enrichment, like you're looking up data from an API or a database, or you're windowing data. So you're basically creating let's say a window of data where you're collecting data for 5 minutes, and then you're running some analysis, some aggregation over this window, and then you're sending this downstream to some what we call sync. So you're syncing it to, let's say, Amazon S3, or you're syncing it to Elasticsearch or Kafka, all the systems that exist out there for data processing.
So the idea in terms of big architectural chunks is there's some source of stream things coming in, then there's Flink, and Flink does computation over that stream of events and puts the results somewhere. And that could be Kafka to Flink back to Kafka. That could be Kinesis to Flink to S3, but it's a stream compute results.
Correct. Yes.
Okay, well, it seems like we've got it figured out. Now, there might be a little bit more to dig into. Now,
I mean, the question is, how does it do the magic, right?
How does it do that? And before we even get there, I want to talk about what a stream is, because it has always seemed to me that Flink has had an interesting set of opinions there, an interesting approach. That, when I think stream processing, I'm automatically in the mode of unbounded data. That I kind of have a Kafka background, so I'm thinking there's a Kafka topic, there's messages, there'll always be more messages. I'll get my next message and I'll do my compute on it, and away we go, and it never ends. Flink is intentional about this distinction between bounded and unbounded data. Talk to us about that a little bit. What, in Flink terms, what does that mean?
Yeah. So maybe that's also a good opportunity to quickly talk about the history of Flink. So it was actually created more than 10 or 12 years or so ago at a university in Germany, Technical University in Berlin. And the PhD students there were studying traditional database systems like pipelined execution and all the stuff that has gone into database research. And they looked at Apache Hadoop back in the day, which was really popular. And they found that there's quite some things there where all the research from database has been ignored, basically, when or just some parts of it have been considered, and that's why they wanted to implement a better Hadoop. So initially, Flink was actually exposing batch processing APIs, and you can still find these APIs in Flink. It's called the data set API instead of the data stream API, and it has all the stuff that you also have in MapReduce, like in Hadoop MapReduce, but also more on top. So MapReduce is basically two operators, and the Flink data set API has additional operators like a join operator that is highly optimized for really big data. And then at some point, we noticed that a lot of people are really interested in stream processing, and there were no frameworks around that provided exactly once guarantees and high performance. And that's when we basically decided to put a stream processing API on top of the Flink engine. And since we used a pipelined execution engine, which allows you, so basically the batch engine was already, or the Flink as a batch processor was already using stream processing underneath. And we just exposed the engine as a stream processing engine as well. And that's how Flink is able to support both batch and streaming workloads with the same underlying engine. And it has always been doing stream processing. We just initially only exposed the batch processing part of it. Because if you think about it, the only difference is that in batch processing, it's a finite stream. And if you have this kind of information, you can do more optimizations. You can, for example, store all incoming data temporarily, sort it, and then forward it or something. And that's something you cannot do in a stream because a stream will never end. Like if you would try to store an entire stream, then you would run out of disk space eventually. Sorry, I think we're going a little bit too deep.
No, not at all. No, this is exactly. I mean, Flink kind of has this interesting little plank in its worldview that is worth talking about. That it tries to be agnostic about whether data is streaming or batch or bounded or unbounded, I think is the more precise term. And these days, if you just kind of look out in the world and you were a software architect from Mars and you just arrived here and you're trying to learn about our things, you'd think, well, Flink is a stream processor. It didn't start that way. And so it's got this interesting opinion that, I guess the way I look at it is, suppose you've got batch data sitting somewhere. There's data in a pile in storage of some kind. There's no such thing as a giant pile of undifferentiated bytes, right? There's always a structure to it. If it's a text file, it's an ordered collection of lines. So that can be a stream. It's just an interesting way of looking at it. You can always turn the records into a sequence.
And Flink actually has something called the hybrid source that allows you to start the stream processor from a batch source. And once the batch has been consumed, let's say all your files in S3 has been consumed, it transitions over to a Kafka topic. So you can actually do a switch over from historic data to real-time data with Flink. And this allows you to, and Flink has more features for, let's say, historical data processing with the streaming API. So Flink has a concept or has abstractions for handling event time. And event time is basically a mechanism in Flink that considers the time when an event has happened. So if you have historic data in your S3 bucket from 10 years ago, it will take the timestamps on all your records and consider them as the time for all the processing, like for all the real-time processing. So if you have, for example, a window that collects, like if you're creating buckets of 5-minute data in your streaming pipeline, you can use event time also on historical data and create from the data from the last 10 years, you can create 5-minute buckets. So this is basically reprocessing on historical data with a streaming engine. And once you're done with the reprocessing, you can transition to the real-time processing. And this allows you to consider all the historical context of a problem as well.
Right. Like you have, giant S3 buckets full of Parquet files and then a Kafka topic. That's the current stuff. You can actually have a single API lens on that. And I guess you write the code once.
Exactly. You write a code once for everything.
Yeah. Okay. Now there's probably good if we didn't talk too much about time. That might be a future episode because I know that's an extremely complex topic. If we get there, that's fine. But again, there's kind of like the API lens, which I want to cover next. And then there's the architectural and operational lens. And this is, again, a thing where Flink, I have always read kind of like this agnostic approach to how it's deployed and what it means to be Flink operationally. So walk us through the architecture. Like we got the block diagram, but what's inside the middle block that does the stream processing and where does it run and how does it operate?
It's more like a coordinator and the workers. There's one central node where you submit your Flink streaming applications. And then the central node is splitting this work into all the what we call task managers. And the task managers is where the data is processed. Like the task managers run Kafka consumers, Kinesis consumers, the window operators, and all that stuff. And they basically periodically report back to the central job manager, how they're feeling, and if something goes wrong, stuff gets restarted, and they take care of the checkpointing, which is our mechanism for failure recovery. So we periodically take a checkpoint of all the state that is present in all the operators. And in case of a failure, we can go back to the last successful checkpoint and restore from that.
Got it. And so the two architectural components I should know about are basically the, did you call it coordinator, controller? Job
it's
manager.
It's called job manager and task manager. Yes.
Okay.
So the job manager manages the jobs that you submit to Flink, and the jobs are broken into smaller tasks. And these tasks are executed on the task managers.
Got it. And so task managers are the things that scale. We'll probably want a lot of those. They've got individual tasks running. Got it. Okay.
Yes.
Now, there's this other thing that comes up if you're just kind of reading the docs at the top level. Flink doesn't care how you run it. There's Yarn, there's Mesos, there's Kubernetes. Talk to us about that kind of from that operational lens just for a minute. What is that?
So what I just described are basically the building blocks that we provide. And then there's different ways of putting these building blocks onto a resource manager. And I think we dropped support for Mesos a year or two ago. And Yarn is also not really used anymore for new deployments. Kubernetes is the thing now. And and I think by now, so there is a new project within the Flink project called the Flink Kubernetes operator, and I think that's the recommended way nowadays of deploying Flink on Kubernetes.
Gotcha.
So that allows you to define a custom resource in Kubernetes that describes your cluster, like what you want to run there, how many resources you want for it, and then the operator takes care of deploying your job manager and your task managers. But you can also roll your own deployment. So you can also deploy Flink, like take the components of Flink, like put the JVMs into some pods and they will connect to each other and start working.
Gotcha. Or, some local demo. I can run the JVMs and, make sure they find each other.
Yeah. I mean, you can, we provide also just a set of bash scripts. So if you want, you can also just start a cluster with a script that SSHs into the machines and starts them. So there's really a lot of options. I think that's potentially a reason why some people think that Flink is complicated, because there's so many options.
Sure. Yeah.
But Kubernetes is the way to go nowadays.
Certainly, that makes sense. And that's a difficult tension. I absolutely get where that comes from, because from your standpoint, and just our standpoint as engineers, you sort of don't want to constrain. You're providing an infrastructure layer. Your quote unquote customers, clients, users, they're other engineers. You don't want to constrain them, right? Like, hey, we don't care how you run this. Everybody's got their own different way, and we would rather be flexible. Look, it's just some JVMs, and that as a guiding design principle strikes me as wise. But then when you're just walking up to the thing trying to figure it out, it feels like there are extra layers of decisions to make. So I like the, hey, look, here's a Kubernetes controller. This is how everybody does this. Just do that, and it's fine. So
yeah.
Where talk to me about state. I mean, that's always the hard problem in this kind of stuff. So where does state live? And boy, top level approach to how Flink manages state. That's where stream processors get interesting.
Yeah. So to quickly define what state is, in Flink's case, it is, for example, the current offsets of the Kafka topic that you're reading, or it is the current contents of a window that you're currently building, or some running aggregate that you're building. And this can really go into the terabytes. So if you have a sufficiently large cluster, you can really store terabytes of state in a Flink cluster. And there's two options for storing state. One is on the JVM heap, and the other is using RocksDB. And RocksDB is a key value store, I think initially developed by Facebook. It's not really something you have to install. It just comes with Flink, or you add like a jar, and then it's just from an operator perspective, it's a special file format on your local disk. And nowadays, you usually have like a local SSD or a bunch of SSDs, and Flink will use these local SSDs for storing your terabytes of state in your cluster. And this is how you can store more data in state than you have available in memory, or than you have available as main memory in your cluster.
Got it. That makes sense. By being off heap and being in RocksDB.
Yes, and that's the let's say live state set side of things. And then there's the other side of periodic checkpoints for failure recovery. So let's say you have a cluster with like 100 nodes and you have a terabyte of state, and you want to create a checkpoint once per minute. This means that once per minute you have to upload 1 terabyte of state from all your machines to a durable storage like S3. And Flink can do that. And Flink will also do that quite efficiently because it has a bunch of optimizations. So it supports incremental checkpoints, which means it only uploads the diff since the last checkpoint. And it also supports asynchronous uploading. So the processing is not interrupted while we wait for the files to be uploaded. So you create like a quick interruption, and then you start in the background uploading the data to S3.
Got it. Checkpoints usually go in S3 these days.
Yeah, or whatever you have. Like if you're in Azure, it's their S3 thing. Yes.
Yeah.
And then Flink also offers and these checkpoints are controlled by Flink for recovery purposes. And then there's something called save point. And with a save point, you as a user or an operator of a Flink application can trigger a special kind of checkpoint. And with a save point, you can, for example, take all your state of an application and migrate it to a different cluster. Or you can take your state, shut down the cluster, and upgrade the Flink version, or upgrade your application, or scale up your cluster or scale down your cluster. So these are, let's say, operational use cases for save points. But you can even go further and do, let's say, time travel. So you can take save points once per hour. And if you find out that you deployed a new version of your Flink application, but it contains a bug, you can go back in time to an older save point and start the processing from there. So you can go back like 3 hours and run a newer version of your streaming application with your bug fixed.
Okay.
So it will do a little bit of reprocessing. It needs some time to catch up to reprocess the data from the last 3 hours, but then you have a newer version deployed.
Sure, with the correct results because of the fixed bug.
Yes. Yeah.
Excellent. Okay, so that's basic architectural components, basic idea of how to operate it, kind of some key concepts about what even is a stream, and Flink's interesting opinion there. A little bit of an idea about state. What else should we know if you're just trying to get Flink into your head for the first time? What are the other important things you like to cover?
So I think what's interesting about Flink is it's really flexible. It can cover a very wide range of use cases, from traditional analytics workloads to really low latency workloads. So there are some tuning options in Flink to optimize for these different workloads. But you can also build things like real-time applications. Let's say you have a mobile app and you want to send people a notification when they enter your store to give them, like a discount voucher or something for their shopping. So this is also something you can build with Flink. And there's a company in the UK, they're building a social network it's a few years ago, but they've been building a social network for car enthusiasts. And this whole social network is basically run on Apache Flink. So whenever you click, whenever you like something on the social network, whenever you post a comment or a posting, all these events go into Kafka topics. And then from these Kafka topics, Flink computes all the timelines and all the comment threads and everything and puts them into Elasticsearch. And then the website is basically served from a cluster of Elasticsearch machines. So you can really build like a social network with Apache Flink as well.
Yeah. Oh, wow. All right. Lots more to talk about. I would kind of like to know how to use it from a developer's perspective. Mm-hmm. But for that, we will have to tune in next week. So for today, my guest has been Robert Metzger. Robert, thanks for being a part of the Real-Time Analytics podcast.
Thank you. It was great.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.